This is COMP1010 at the University of Manitoba, and I'm Dr. Celine Latulip. In this video, I'm going to talk to you about integer operations and the order of operations. So we've already talked a little bit about the int data type. It's for whole numbers, and we're going to talk more about that. So one thing that you need to know is that when we think about numbers, we don't think that there's a biggest number. Programming languages have limits on the size of numbers they can store. So we are going to use a certain amount of memory to store an integer, and that amount of memory limits us to values that are in this range. Now, this is a pretty massive range from this really, really large negative number to this really large positive number. And if you wanted to understand sort of the advanced reasoning for this, it has to do with how many numbers can be stored with binary bits in the computer. All right, so we can use ints as literals in our program, which means we're just typing the number directly into our program. But you have to be careful about the way you do this. So these are all valid examples of typing a literal int into the program. So the value 25,437 can be typed this way. You can put a plus sign at the front of it to denote that it's a positive number, and that's allowed. You can put a negative sign at the front of it, which now says that this number is negative 25,437. So those all work as ways to type these literal values into the program. You can't add other stuff when you're typing in values. So if you were trying to store a monetary value, you don't put in the dollar sign. You don't put in units like kilometers or inches or ounces or anything along those lines. And then you can put decimal signs in numbers, but not when we're trying to store int numbers. We'd have to use a different data type for that. So we don't want to do this, even if it's a 0. And in some countries, the convention is to put a comma for every 3 spaces in a large number. And again, we don't want to do that here. So these would not be valid ints. We don't want to use this formatting. For any of these, we would just want to type something like this. All right. In terms of operations, when we have integers, the basic operations that we can use are plus, minus, multiply, divide, and remainder. So plus and minus work exactly as you would think that they work. In programming, we're going to use the star or the asterisk sign for multiplication, so you don't use an X. And division and remainder are a little bit different than what you might be used to from math, so they need more explanation. Okay, so integer division gives you a quotient and a remainder. So the quotient is how many times the bottom number goes into the top number, and the remainder is what's left over at the end. So 57 divided by 10, 10 goes into 57 5 times, our quotient is 5. And then there's 7 left over, so that's the remainder. 13 divided by 5, 5 goes into 13 twice, and then there's 3 left over, so that's the remainder. So the division operator in programming gives you only the quotient part when you apply it to 2 integer values. So in processing, if we do 57 divided by 10, we're going to get 5. We won't get 5.7, as you would expect if you used a calculator or if you were doing math. So 49,999 divided by 10,000 gives you 4, not 4.99. And note that even though 4.99 is really close to 5, this doesn't round up. You just get the quotient. So the result is what we call truncated. It's not rounded. If you want the remainder, then you need to use the percentage sign, which is the mod operator or the modulus or modulo operator. So if we, instead of doing 57 divided by 10, if we do 57 mod 10, then what we get is 7, which is the remainder from that division operation. So 23 mod 2 multiplied by 11 gives you 22, but we've got 1 left over, so 23 mod 2 gives you 1, etc. All right, one of the things that these types of intricacies can kind of trip you up when you're programming, and one of the best ways to figure out what's going on when the program isn't behaving as you expect is to use println for debugging. So that's for finding a bug or a problem in your program. And so if you do something like println x, then processing will go and find the variable x and print out whatever's inside that variable to the console in the processing programming environment. And you can put expressions in here, and the expression will be evaluated and the result of the expression will be printed out. So if we do println 79 divided by 10, it's going to do that division and it should return and print out 7. If we do println 79 mod 10, then it should return the remainder, which is 9. So let's switch over to processing and see what that looks like. So println, and the ln just stands for line, so it's like a short form for saying print out a line, and there'll be a carriage return at the end of it. So println 79 divided by 10, and if we run that, we see down here that we get a 7. And if instead we do 79 mod 10 and we run that, instead we get a 9. Okay, so you can also add text to your println to help you figure out what's being printed out, especially if you've got multiple println statements. So let's have a look at what this looks like. In this case, we might say 79 mod 10 gives, and we have to put text in the quotations, and then we need to put in a plus sign. So this basically says print out this text and then print out what the value of this expression. So let's run that. And now you see here we say 79 mod 10 gives, and then we have the value 9. There's no space in there, so we could make this look a little nicer by putting a space in there. And we can copy this and paste it twice. And we can do one that's division and run this. And now we see 79 divided by 10 gives 7, 79 mod 10 gives 9. Okay, so println, really useful for figuring out these things when you're not sure exactly what processing will do. It is important to note that when you're combining text and expressions, that you do the text first. Otherwise, processing will try to treat everything as an expression, and that won't work well with text. Okay, so let's look at some examples of valid expression assignments. So when you're doing an assignment, you can just use a literal. We've seen literals, those are just typing in the number. You can use a variable or identifier, so this will get whatever is in X and put it in num. You can do regular sort of standard math expressions, and this is actually called an infix operation because the operator, the plus sign, is in between two values. So get whatever's in X, add it to whatever's in 5. This works the way you would expect. This is a prefix operator, so this says take this value and multiply it by -1. And this is a postfix operator, and it says take this value and then do something to it. And we're going to talk a little bit more about what that means. And then here's an expression that's a whole bunch of operations. It's got some literals, it's got some variables or identifiers in it, and we have to remember and know what the order of operations is in order to evaluate this. And this is sort of the same thing as above, but we've put in parentheses to control what order things are done in. Okay, so speaking of order of operations, it's important to know how things are going to happen. So if you put things in parentheses, those are going to happen first before things that are not in parentheses. And then prefix operators, the plus or minus, that's to the left of a number, that will happen next. And then multiplication and division and remainder, those things take precedence. So they happen before we do addition and subtraction. Okay, so this means that 3 times 2 plus 5 times 6, we're going to do the multiplication because it's higher precedence first. So we're going to do 3 times 2, that'll be 6. We're going to do 5 times 6, that'll be 30. So, and then we'll add the 6 to the 30. So this will give us 36. And you can put these brackets in here. You don't need to, but they help with readability and they help make it clear what you're trying to do. All right, so let's look at a couple of examples in processing. All right, so let's clear this out. And what we want to do is type this program over here. So size 500, 500, int percent equals 33. So we're trying to draw a line that goes a certain percentage across the screen. And the target is the percentage divided by, say, the size of the screen. So a percentage has to be out of 100, so we do percent divided by 100, and then our screen width is 500. Oops, and I forgot my equal sign for assignment. And then we actually want to draw something with this. So let's draw a line from 0 to 200, from 0 to 250. So that's 0 over 250 down to target 250. Now, if we were to do this in math, we would say that 33 divided by 100, that's going to be 0.33, and then we're going to multiply it by 500. So sort of a third of 500 should be like somewhere in the 170 range or something like that. That's what you would expect if you were just thinking regular math. But let's see what happens when we run this program. There's no line. Uh-oh, what's going on? And this is where the division is tripping us up. So in this program, 33 divided by 100 is 0. And we can test this out because we can do a print line of target. And if we run this, we'll see that target is 0. And it's because we've done this division and it's doing integer whole number division, and 33 divided by 100 is 0, and 0 times 500 is 0. So we're drawing a line from 0 to 50 to 0 to 50. So that line isn't going anywhere. So that's not good. So how do we fix this problem? Well, the easiest way to fix this problem is to just change the order in which we do things. So let's take the 500 and put the 500 at the front, and let's say 500 times percent. So this will multiply 500 times 33, which will give us a really big number, and then divide that whole thing by 100. So let's run this. And there we go. There's our line, and target was 165. So this calculation worked because we calculated the bigger number first and then divided by the smaller number. There's a couple of different ways that we can do this in terms of how the order of how you write it, but this will work. Okay, so hopefully that gives you a good sense of how you use integers and literals and operations and the order of operations for assigning things like this. All right, thanks a lot.